Hello all, welcome to my channel. I'm Vivek Gaurav and I'll be teaching you dynamic programming. And before we go ahead, a humble request from my side, please like and subscribe to my channel and please click on the bell icon so that you'll be getting notified every time a new video is coming. Now, let's get started. Today we are going to discuss about introduction to coding, and the topic for today's discussion is basic of computer, what is programming language, what are the different programming language approach that we have, and what is the compiler, interpreter, assembler and linker. Now out of these you must be knowing some of them. Okay, but the whole idea of making this video is to make you understand the definition, because sometimes what happens is that you know what does that mean, but in order to put it in the right words you find it difficulty. So the whole idea is that to give you a brief idea about all the programming terms or the technical terms that are used in the programming language, so that you can be aware of them. Okay, so make sure you watch the complete video to get a better understanding of all of them. So let's go ahead. So what is the computer? We all know, if you are watching this video, so definitely आपको पता है कि computer क्या होता है. You already have a good idea about that, but in technical terms, what is the computer? Let's try to understand that. So an electronic device operating under the control of instructions is stored in its own memory unit that can accept data input, manipulate the data according to the specified rules, which is called processing, and produce information called output from the processing and store the result for future use. Now यहाँ पे आपको ना कुछ words हैं जिस पे आप लोगों को ध्यान देना है. वो words क्या हैं जिस पे आप लोगों को ध्यान देना है? वो यहाँ पे ये है. पहला तो हो गया कि input. ठीक है, this is the first thing. Second thing is that a memory unit. Okay, this is the second word. Third, we have processing, and the fourth is called output. Okay, so these are the four words where your focus should be. So basically, what is a computer? Computer has its own memory which can accept data. It manipulates the data. Okay, manipulate the data, which is nothing called processing, and then it produces the output. Okay, so whenever you use a computer, the whole idea is that either you are going to give some kind of input or you are expecting some kind of output, right? You are giving some kind of input to the computer and you are expecting some kind of output from the computer, and in between you want some manipulation. Okay, in case you feel like manipulation is not the right word, then you can use processing, right? You want some processing to happen in between. That's the reason you use a computer. So basically there are four major components. One is memory unit. Okay, if I'll talk about that, one is memory unit, right? The second is that input. The third is processing or manipulation, right? And the fourth is nothing but the output. These are the four important parts which happen in a computer. Okay, now let's go ahead. So what does the computer do? So computer takes input, it processes the input, it gives the output based on the processing that has happened, and if required it can store the data as well. So what we were talking about, that what a computer does, so these are the four processes, or these are the four things which a computer does: input, processing the input, producing the output, and storing the result, which if required. Okay, now let us go ahead. So input device, you all know what is an input device. Anything which is used to give any kind of input to the computer is called input device, right? So any hardware component that allow you to enter the data, programs, commands, and user response into a computer is nothing but a input device. Example: keyboard, mouse. Like right now when I'm typing using a digital pen, so you can see a digital pen also a kind of input, right? With that I'm giving some kind of input to the computer, right? So that is nothing but an input device. Going to the output device. So what is an output device? Output device is nothing through which you can see the result. Like right now if you are watching my video in your laptop or in your PC or in your phone, so that is nothing but a kind of output device, right? So output device make the information resulting from processing available for use. Example: printer can also be an output device, impact printer, non-impact printer. So we are not going into the hardware part, but basically just to give you a fair idea that that is also kind of an output device. Okay, then we have display devices like CRT or LCD monitor. These are the display devices that we have. Now going ahead, so what is the system unit? Okay, so let us talk about that. So the motherboard or system board is the main circuit board of the system unit. You all know that, right? You might have used this word 100 times in your computer life or your student life, that motherboard kharab ho gaya, system is not working, you need to replace that, something is like. Okay, so the motherboard is the main circuit board of the system unit, and the processor, also called as the central processing unit, CPU. Okay, CPU, the full form is central processing unit, interprets and carries out the basic instruction that operate a computer. So it is the CPU which carries out the basic instruction that operate a computer, and the control unit interprets the instruction. So there is a control unit also which interprets all the instruction which you are giving to it. And then there is something called as ALU, which is called as arithmetic logical unit, okay, which performs a logical and arithmetic processing. So in case you are doing some arithmetic and logical operation, so which does that, which part of the computer does that, it is called ALU, arithmetic and logical unit. Okay, and memory, also called as random access memory or RAM, consists of electronic component that store data, instruction and information as needed by the processor, right? Like you must be aware of these terms very much, right? RAM तो सबको पता है, क्योंकि आज के फोन में, in today's phone you need at least 4 GB of RAM. You want that 4 GB of RAM देना भैया, 8 GB वाला फोन देना, 8 GB वाला फोन देना, right? Because आपको PUBG खेलना होता है, आपको games खेलने होते हैं, high definition games, so you need a big amount of RAM. Similarly for the computer also, RAM is nothing but like random access memory, which consists of electronic component that store data, instruction, information needed by the processor. Processor को जैसे जैसे वो information चाहिए होगा, वो RAM उसको available कराता है. Now coming back to computer software. So what is computer software? The system software consists of programs to control the operation of the computer equipment. So like when you are running a computer, you need to control it, right? Like right now I am presenting it using a like PowerPoint presentation, right? So this is PowerPoint presentation is nothing but a kind of a software. So system software consists of programs to control the operation of computer equipment, and instruction in the operating system tell the computer how to perform the functions of loading, storing and executing an application program, and how to transfer data. Okay, so this is what the role of an operating system is. What the operating system does is that operating system tell the computer how to perform the function of loading, storing and executing an application program. वो जो application program आपको use करना है, वो operating system ही वहाँ पे करने वाला है. Okay, so when a computer is turned on, the operating system is loaded in the computer's memory from auxiliary storage, which is called as booting. Booting आप लोगों ने बहुत बार use किया होगा, but what is booting actually? So when a computer is turned on, the operating system is loaded into the computer's memory from the auxiliary storage. Auxiliary storage से computer के memory में आ रहा है, and that whole process is called as booting. Okay, and most computer uses use an operating that has a graphical user interface, GUI. All the computer today use graphical user interface, which is known as GUI. Okay. Now the next thing is that language. So like right now, in order to communicate with you, I'm using two languages. Like I'm using Hindi and or English, right? Hindi and English both, in fact. Hindi English दोनों का हम use कर रहे हैं, right? So humans have a language which is used to express feelings and understand other person's expression. It can be oral or gesture kind of communication. But when it comes to computer does not understand our language. They do not understand Hindi, English, Tamil, Telugu, Bengali and Marathi and Gujarati and all other kind of language. They do not understand that, right? So what do we need to do? How are we going to make the computer understand that? So computer language are the languages by which a user command a computer to work. Okay. So computer language is nothing but a language through which we command a computer. So basically there are two things. One is called coding. Okay, you might have heard this word millions of times, in the recent years, and the reason is being it is a buzzword these days. Okay, so what is coding? So coding is all about instructions. Coding is all about instructions, or we can say command instructions, or the commands which we give to the computer. Okay, so what happens is that, assume that I am your robot. Okay, assume that I am your robot and you want me to dial your friend's number. Okay, so you directly cannot be that call my phone, okay, call my friend. I will not be able to understand that, because I am a robot. I do not have a common sense of mind. So what do you have to tell me is that you have to tell me that pick up the phone. So I'll pick up the phone. Then what you have to tell me is that you have to tell me that open the dial screen. So I'll open the dial screen. Then you'll have to tell me that go to the phone, go open the lock screen. Sorry, first of all, not the dial screen. First of all, you'll be telling me open to lock screen. Then you'll be asking me to go to the dial pad, and then you'll be telling me to dial the number. Then you'll be asking me to click on the call button. Then I'll be able to call that person. Right, so you gave me a series of instruction. Now if you miss any of the instruction, do you really think I'll be able to call your friend? Of course not. That will be literally impossible because I cannot fill up any of the gaps in between which you have left, right? So you have to give me the instruction in sequence of order. So that is nothing but coding. Now, in order to give this kind of instruction, right now you were using English and I was able to understand it, but a robot does not understand that. So you have to talk in that in their language, and for that we use programming language. Okay. So what is the computer pro language? So computer language are the language by which a user command a computer to work. That is called computer language. Now going ahead, coming back to programming language, which we were talking about just before. So programming language is nothing but a set of words, symbols and codes that enables humans to communicate with the computer. Okay. And there are different examples of programming language. If I talk about like C, C++, Java, Python, right? C Sharp, and many more, right? There are many more. There are n number of languages which are there today, and people use it as per their convenient and as per their requirement as well. Okay, so now programming language are used to write application programs which are used by the end user. Now who is the end user here? So end user are those people who use an application. So basically I can say that, end users are nothing but consumers. Okay, they are the one who consumes the application or consumes the software that you have made, or the application that you have made. Okay, so programming language are used to write application programs which are used by the end users, and programming languages are generally used by professional programmers to write programs. Okay, so programming language, who use programming language? Used by the professionals, and sooner you people are going to be those professional programmers, right? Because you are the one who are going to use your creativity along with coding to make a difference to this society, to make a difference to this world, right? So programming language are used by whom? Programming language are generally used by professionals programmer to write programs. Okay, now the next topic that we have over here is that the development of programming language has improved considerably with the ease and ability of programmers to write powerful application program that can solve any task in the world today. And that is the reason why there is so much of, so much of emphasis on coding. The reason being is that the development of programming language has improved considerably in the recent years, right? And with corona, with this COVID-19, or with this pandemic, we are already 10 years ahead of time, 10 years ahead of time. What was supposed to come in the year 2030 has already arrived in 2021, so we are already 10 years ahead of time. Okay, so has improved considerably with the ease and ability of programmer to write powerful applications program that can solve any task in the world today. And then that is then only you get paid. So you need to solve someone's problem. So whole idea of coding is that you identify the problem and you solve it, right? That is the whole idea that you need to do. So each programming language has its own distinctive grammars and syntax. So like in English we have grammars, right? In English we have something called as grammar, isn't it? In English, we have something called as grammar. So similarly, every programming language has something called as syntax. Okay, they have something called as syntax. So if I use this word syntax, basically I imply the rules and the regulation that a programming language has. Every programming language has certain rules. Like if I talk about C, so every statement in C has to be terminated by a semicolon. All the keywords has to be in a small letter. So these are the rules that are there, and you need to follow that. If you mess up these rules, you are going to get error. Okay, which we'll discuss in the upcoming classes. Okay, so these are the things that you need to understand, and you need to abide by that. So every computer programming language has its own distinctive grammars and syntax, and its own manner of expressing ideas. In principle, most computational tasks could be accomplished by any of the language, but the program would look very different. And moreover, writing a program for a particular task could be easier with some language than the other. Okay, so every programming language has its own syntax. Okay, like Python has a different syntax altogether, C has a different syntax altogether, C++ has a different, C++ more or less has the same kind of syntax, right? But Python and C++ are completely different. Okay, so it could be like, you might find it some programming language syntax to be easier as compared to other, but that all depends on, that is nothing, that is a subjective topic. Something which is easy for you might be tough for someone, or something which is tough for you might be easier for someone. Okay, so every programming language has its own distinctive grammars and syntax. So next time when this word comes into comes into any of the slides, or you hear it somewhere, you know what does it mean. It means rules of a programming language and its own manner of expressing ideas. Okay, so now going ahead from here, So programming language, so there are hundreds of programming language which exist today, and each language has its own standard or rules for writing the commands or instruction. As I talked about, there are hundreds of programming language which are in use. People use it as per their convenient and as per their requirement as well. Okay, and every language has its own standard or rules for writing the command or instruction. More or less they remain the same, but of course they do change from time to time. Okay, example of programming language, if I'll talk about basic, Pascal, C, Smalltalk, these are the example of programming languages that are there, right? And you might not be knowing about much about basic or basic you might have read in your school days. It might be possible, but if not, we are going to start with C, and then we are going to cover Python and all those things. Okay, so now let's go ahead. So there are different levels of programming language. So when programming language came into the existence, okay, they were first into were called as low level programming language, and there were two generations of low level programming language. One was first generation, the other was second generation. Then the high level programming language came into existence, and third generation, fourth generation, and fifth generations are part of that, and all the other one which are coming are automatically part of the high level languages. Okay, so programming language are basically divided into two parts: low level language, high level language. So now what is programming language? Let's understand more in detail. So to build programs, people use languages that are similar to human languages. Okay, it was very difficult. It was very difficult to, only a certain group of people were able to do coding. Rest of the other people were not able to do coding. So it was very much essential. It was very much required that they come up with some kind of language which people can understand, people can use to do coding or programming. Okay, so to build programs, people use language that are similar to human language, which is called as computer language, and the results are translated into machine code which computer understand. Okay, now there is something which you need to understand. The what you write, okay, let's suppose that you are writing a program in C, so hash include and all those things you will write. Okay, now this is called as source code, which you'll understand in the coming slide. This is something called as which is source code. Computer does not understand this part. Someone convert this part into something called as object code or machine code. Okay, then the computer understand that. Okay, because we use English to write our coding, isn't it? We use English words, English alphabet to write our program, and we all know that computer understands 0 and 1. So there must be someone who's converting this English into 0 and 1, right? So who is that? We'll be understanding about that them as well in the coming slides. Okay, so programming language fall into three broad category. One is called machine language, then we have assembly language, and then we have higher level languages. So what is machine language? So machine language, which is basically the first generation language, are the most basic type of programming language consisting of strings of number the computer hardware can use. And that was the reason why a limited number of people, a very limited number of people use these language, number of people, as compared to high level language, like the number of coders that you have today. And when you will talk about machine language, there will be, you will hardly find 1 or 2% of that. This is what my guess is. I am not talking about any data. This is what my guess is. Okay, because I have seen a lot of coders, but I have hardly seen anyone who uses machine language. Okay, they are very specific group of people who do a very specific task. Okay, so machine language, which basically is the first generation language, are the most basic type of computer language consisting of strings of numbers the computer's hardware can use, and different types of hardware uses different machine code. So it was specific to different machines. For example, IBM computers use different machine language than Apple computer. So the point was that even if you learn one language, right, learn one language, it does not mean that you will be able to do all of them, because you need to make certain changes, and every language was different, so you need to adapt yourself to different languages. Now the next thing is that assembly language. So assembly language basically is the second generation language. So machine language we saw, that was the first generation, this was the first gen, it was the first gen. So assembly language is the second generation language. Okay, it is the second generation language, are only somewhat easier to work. So machine language we talked about is very difficult to work with, but they wanted, to a wider group of people to use the programming to do coding. So they came up with machine language, with assembly language, which was somewhat easier to work with as compared to machine language. And to create programs in assembly language, developer use cryptic English like phrases to represent strings of number. Like if I'll tell you some example, like print. Okay, print might not be exactly the same kind of statement, like, but I'm just giving you an example. Okay, so developers use cryptic English like phrases. So now from strings of number, they started using English like phrases to represent strings of number. Okay, that was the advancement from first gen to second gen, first gen to second gen. That was the advancement that happened. After that came the third, fourth, and fifth. So third, fourth, and fifth generation, which was known as the higher level languages. Okay, so higher level languages are more powerful than assembly language and allow the programmer to work in more English like environment. And here all are English words. Okay, you do not have to go beyond your keyboard, you do not have to type anything other than that. Okay, more or less everything is there in your standard keyboard which you get, right? So it is more like English like environment. So high level programming language are divided into three generations: the third generation, fourth generation, and fifth generation, and each generation is more powerful than the last one. So the fourth generation is more powerful than the third one, and fifth generation is more powerful than the fourth one, right? And it goes. So now we are in the fifth generation, and it is the best, you can say that. Okay, so now when we talk about programming language, so each programming language has a different kind of approach, and basically we have two programming language approach. One is called a structured approach. Okay, one is called a structured approach, the other is called object oriented approach. So let us try to understand that what is structured approach and what is object oriented approach, and what is the difference between them. Okay, so when we talk about structured programming, okay, so in structured programming we subdivide the whole program into small modules so that the program become easy to understand. Okay, so what we do is that, let's suppose that we have a big task, we divide the task into different part like 1 2 3 4 5. Okay, so if I have to give you an example, I can give you an example like this. So let me use a board over here. Okay, a board over here. So let's suppose that if I have a, like, how do you say, if you have to find the sum of, if you have to find the sum of two numbers. Okay, find the sum of two numbers. Okay, now what you will be doing is that you will be dividing into three parts. First, take two numbers, right? Because you need to take the numbers, you need to take the two numbers. Then what do you need to do is that you need to find the sum, right? You need to find the sum. And the third thing that you'll be doing is that, what you'll be doing is that you will be printing the sum. You will be printing the sum. These are the three steps that you'll be doing. Okay, so now there was one task of finding the sum, and how did you do it? You divide it into three steps. Step one is what? Step one is, taking the two number. Step two is what? Step two is finding the sum, and step three is what? Step three is nothing but printing the sum. So this is how you are going to do it. Okay, so now the purpose of structured programming is to linearize the control flow through a computer program so that the execution sequence follow the sequence in which the code is written. Okay, I don't know whether that board will be available right now, but okay, it is not available anymore. So what did we do over there is that we just did one thing, right? There were three steps. One was that taking the number, taking two number, right? Taking two number, and then what we did is that, adding it, or finding some, right? Finding some. And the third step that we did was that the third step was printing it, right? Now the point is that if we are making these three step, if we are making this three step, can you mess up with the step? Can you do step 2 before step 3? And the answer is a clear no. Until and unless you have two numbers, you cannot find the sum of two, and until and unless you find the sum, you are not able to print it, right? So basically what happened is that it became into sequence. So there were two terms which we used. One was linearize and the other was sequence. So now you understand what is linearize and sequence. When we are breaking down into steps, we are actually asking you to go point by point, to go linearly, okay, one after the another, and in a particular sequence. If you mess up with that, you are not going to get the result. Okay, so the purpose of structured programming is to linearize control flow through a computer program so that the execution sequence follows the sequence in which the code is written. In which sequence the code has been written, you are going to follow exactly the same thing. Okay, this is what the purpose of structured programming is. Now, so the dynamic structure program that resemble the static structure program, the dynamic structure of the program, the dynamic structure of the program resemble the static structure of the program. Okay, now what is dynamic, what is static? Static means something which cannot, which is not changeable, right? And dynamic means it is easily modifiable. Okay, it is easily modifiable. Okay, so now what happens is that this enhances the readability, testability, and modifiability of the program. Now the question is that how does the readability increases, how does the testability increases, and how does the modifiability increases? So now let us take an example over here. Okay, let us take an example once again over here. And what we had is that there were three steps. First was take two number, right? Second was that find the sum, right? Find the sum. And the third was what? The third was print the sum. Okay, print the sum. So now the first point was readability. So now don't you think that it is much easier to read and much easier to understand the steps that you need to follow? Take two numbers, then find the sum and print the sum. So readability is all about how easy it is for the user to read it and understand it. Okay, testability. If you have to test it, okay, what you can do is that you can make the you can test it, in the first step and the second step. These are the testing scenario that you can do in case you want to test the things. You can give up, instead of two numbers you can give two strings, or instead of two numbers you can try to give three numbers or something like that, and find whether you are getting the right result or not. So this is how the testability can be done. If I talk about the modifiability, okay, let's talk about modifiability. So modifiability means the ability to modify the program. So let's suppose that in the future there is a need to take three numbers, right? Take three numbers as the input. So which two steps I need to follow, which steps do I need to change? So of course, if you can answer it, I know your answer would have been, sir, this a step and this a step. These are the two steps that you need to change, right? So instead of two numbers, what you'll be doing is that you'll be taking three numbers. Take three numbers, right? And then find the sum of all the numbers which you are getting. So right now, let's suppose you are getting a, b, and c. So you'll be doing a plus b plus c. Earlier you were just doing a plus b, but now you'll add c into it. So it will become a plus b plus c. Printing the sum will remain the same, because whatever sum you are getting, irrespective of whether it was the sum of two number or three number or four number, this step is independent of that. So you do not have to make any changes in this step. This step will go like, completely unchanged. Okay, so that's how the modifiability becomes very simple. Okay, the modifiability of the program becomes very simple. You know where you need to modify it. Okay, now there is one more thing which I want to tell you right now only, is that let's suppose there is an error. Okay, we are getting an error. Okay, we are getting an error. I gave 2 plus 3, but now I am, instead of getting 5, I am getting 23. Okay, now tell me which step the error can be. Which step the error can be? Chances are pretty high that either the error will be in the step number 1, or either the error will be in step number 2. Step 3 is completely is error free, because while printing the error, while printing the sum, you are not supposed to make a mistake, isn't it? Whatever is coming to you from step number 2, you are printing that. So either you have taken something wrong in step number 1, you are not taking the correct input format, or while adding the number you are doing some kind of mistake. So you know that if you have to find the error, either you will go to step number 2 or you will go to step number 3. Step number 2, step number 1 and step number 2. You won't go to step number 3. Reason being is that there are very less chances of any error being there. Okay, so now the finding the error also becomes very easy. Okay, this point will come later on, you will understand that. Okay, so the dynamic nature is the structure of the program that resembles the static structure of the program, and it increases the readability, testability, and modifiability of the program. And this linear flow of control can be managed by restricting the set of allowed application construct to a single entry, single exit format. It means what? You allow the entry at a certain point, and then you allow the program to go from a certain point. Single entry and single exit format. Okay, now why do we use structured programming, or why structured programming is in use? So we use structured programming because it allows programmer to understand the program easily, right? To break down the steps into to break the whole program into multiple tasks or to multiple steps. It's actually going to make it easy for you, because you then do step 1, then step 2, then step 3, right? It becomes easy. And if a program consists of thousands of instructions and an error occurs, then it is complicated to find the error in the whole program, isn't it? If we have just about let's suppose 100 lines of code, so it becomes very difficult to find where is the error. But here what happens is that, but in structured programming, we can easily detect an error and then go to that location and correct it. Okay, let's suppose that instead of that 100 lines, if I divide it into 10 lines each, right? So we know where the error can be, and it becomes very easy for us to go to that place and then figure out the error. The same example which I was giving you, right? If your step 1 is that taking two input, taking two numbers, and your step 2 is finding sum, right? Finding sum, and then is print. The third step is printing. And if you are making an error, chances are pretty high that either you are making an error in step number 1 or step number 2, because printing there are very less chances. So either you go over there or you go over there and check whether there is error or not, and this saves a lot of time. Okay, it saves a lot of time. So that is the reason why structured programming approach is being used. Okay, so I hope that you are able to understand it. Now let us go about object oriented programming. So in object oriented programming, what happens is that the system is viewed as a collection of object, that is entity. Okay, now there are few terms which is being used in object oriented programming, right? They have something called as class, then we have something called as object, then we have something called as polymorphism, inheritance, abstraction, encapsulation. So we'll not go into the detail of all those things, but we'll try to understand as much as possible. So class is nothing but a blueprint. Okay, what is class? Class is nothing but a blueprint. So let's suppose that when a car is being made, a car is not being made directly, right? First a blueprint of the car is made. Just like a house, you need a design of the house, an architect construct a design of the house. Similarly, you need a blueprint of the house, and then what happens is that, and then the car is actually made. The car is actually made. So the final car is nothing but the object. Okay, so when I talk, or when I say object, I refer to the car, which is a real world entity which you can actually see. But when I refer to the class, it is the blueprint. Okay, so in object oriented design method, the system is viewed as a collection of object, which is entities. Okay, and the state is distributed among the object, and each object handles its state data. Every object has its own data. For example, in library automation software, each library representative may be a separate object with its data and function to operate on these data. Okay, let's talk about, in case you are finding it difficult to understand, then let's take another example. Like, we all can have the same car, same model. Okay, but each car of us is our own car, right? And each car has its own functioning, right? My car is my car, your car is your car, my data is my data, none of your data, my business is my business, none of your business, right? So similarly, what happens is that if I talk about library automation software, which all the libraries happens uses, okay, each library representative may be a separate object. Each one of them is separate, it has nothing to do with the other one, right? And they have their own data and functions to operate on these data. Okay, so the task defined for one purpose cannot refer or change data of the other object. Isn't it? Like if I have some malfunction in my car, that is not going to stop your car, right? So, and if I do something in my one, if I do some modification in mine, it is not going to impact your. So the task defined for one purpose cannot refer or change data of other object. An object have their own internal data which represent their state, and similar objects create a class. Okay, similar object create a class. So in other words, each object is a member of some class, right? Each car is nothing but it came from some kind of blueprint. So classes may inherit features from the superclass, right? And what is inherit features? Like we all inherit features from our parent, like whether it is genes or properties or whatever, right? So the similarly it happens with the classes also. There is something called a superclass, which is nothing but a grandparent or a parent, and classes are nothing but child. So a child of course is going to inherit some of its properties from its parents or from its grandparent, like, so it works exactly like that. Okay, we'll be talking about all these concepts in detail when we'll go to those topics of OOPS concept, right? They will be talking all these concepts in much more detail. Okay, so since this is just an introduction class, I don't want to give you a lot of information. It should not be like you are overwhelmed with a lot of information coming from here. So now let's talk about few terms which we often use. What is assembler? So assembly language is converted into executable machine code by a utility program referred to as an assembler. Okay, as I was talking about, that what you write, okay, when you use high level language, you write code in English. Computer does not understand that. Computer understand which is something called as binary. So there are hell lot of process in between which convert this English into this binary. Okay, an assembler is one such of them. So what is an assembly? So assembly language assembler. So an assembly language is converted into executable machine code. Even the assembly language which you were writing was not directly understood by the computer. There was someone who was converting this assembly language into the executable machine code. Okay, and it was done by a utility program which we refer to as the assembler. Okay, so what is an assembler? An assembler is the one which converts the assembly language into the executable machine code. And how it is done? It is done with the help of a utility program which we refer to as assembler. So an assembler creates object code by translating assembly language instruction into opcodes. Okay, now the next process is that compiler. So what is a compiler? So computer program which reads source code. Now your next question is that what is source code? So as I was talking about, I gave you an example, like let's suppose when you write a code in Python, or when you write a code in C, right, or when you write a code in C, you use English language, right? Like here you write, suppose you write print, okay, you write anything, and here you write hash include and then printf. Okay, so this is nothing but source code. Both of these are source code. Computer is not going to understand that. There must be someone who will be converting this into another form. So that is called as compiler. So what is a compiler? A compiler, thus a computer program which reads source code, which is reading your source code, what you have written in English language and a higher level language, okay, and outputs assembly code or executable code, is called as compiler. So what a compiler does is that it converts the source code into the assembly code or the executable code, and this software converts the code written in high level language into object file, and compiler translate entire program into machine code which can run later on the target computer. So it translate your entire file. You have 10 lines of code, it converts your whole 10 line of code into that. Example of programming language using compiler: C, C++, these are the languages which use compiler. Okay, so again, what is a compiler? A compiler is something which converts your source code into the executable code or into the assembly code. Okay, and it converts everything at once. Okay, one important thing about compiler is that if you have 100 lines of code, it will convert the whole 100 lines of code into object code at once. Okay, so if there are errors at line number 2, 9, 11, it will list down all these errors together at once. Then you go and convert each, correct each one of them, and then you run the program once again. And if there is error free, then it will run. Okay, so this is what compiler. So compiler converts everything at once, and it lists down all the errors which are there in your file. Then what happens is that we have another thing called interpreter. So what is an interpreter? Interpreter translates the source code into machine language while a program is running, one line at a time, unlike compiler which processes everything at once. So interpreter also does the same thing as compiler. Okay, it is also doing the same thing as compiler, but the whole difference is that interpreter does is line by line. Okay, line by line, and compiler does it all at once. So if something is doing line by line, then of course it is bound to be slow, right? And compiler is bound to be fast, right? So what happens is that interpreter translates source code into machine low code while a program is running, one line at a time, unlike compiler which process everything at once. So in this case, a single line is executed at a time and it is time consuming. Okay, so if you have 100 lines of code and if you have errors at line number 2, 9, 11, 19, first it will show you line number 2. Then you go and correct that line number 2. Then it will be corrected. Then it will show error line number 9, because it is correcting one line at a time, right? So whichever line it is finding the error, it is not going beyond that. But compiler, what it was doing is that it was figuring out all the errors which were there, listing down all at once. So you can go and fix all of them at once. Okay, so example of programming language which is using interpreter is that less basic. These are the ones which are using interpreter. Now source code. So we already talked about source code. Source code is in the form of text which you write, right? You are the one who are writing it, right? So your program when you write is nothing but a source code, and source code is human readable. You can read it, and source code is generated by human. You are the one who generated, and source code is the input which is given to the compiler. So compiler, right? Compiler which was converting. So there was an input, right? There was something called as input to the compiler. So what was the input? Input was the source code, right? Input was the source code. You were giving the source code as the input, and what was the output coming? The output was the machine code, right? The output was the machine code. Okay, so source code is input given to the compiler. Then we have object code. So what is object code? Object code is in the form of binary numbers, difficult to understand by you and me. Machine code is in the machine, object code is machine readable, machine can read it, and object code is generated by the compiler. Compiler is the one who generates the object code, and it is the output of the compiler. Okay, object code is the output of the compiler, so that is the object code. Okay, so you have source code on one this side, you have object code on this side, and you have something in between called compiler, right? So it is just like chemistry का reaction. ये था आपका पहला कोई product, बाद में आपका ये बन गया, बीच में एक reaction हुआ, right? So this is input, which is source code. Then compiler came into between, came into picture and gave you object code. Okay, input. This is input, and this was the output. Then preprocessor. So what is preprocessor? So all the preprocessor command written in a high language are processed by preprocessor before compiler takes over. Okay, like this video, this video that I am making right now, this chapter introduction to coding is nothing but a kind of preprocessor thing for you. Okay, introduction. Now what is preprocessor? Preprocessor matlab, like what happens is that ki you use a certain things, right? You use certain things, and then there has to be someone who has to make them explain. जैसे कि अगर आपको हम बताएं, तो जैसे कि मान लेते हैं, एक सिंपल सा एग्जांपल लेते हैं, इधर पाइथन ले लेते हैं और इधर सी प्लस प्लस ले लेते हैं, ठीक है, इधर सी प्लस प्लस ले लेते हैं, राइट? तो इन ऑर्डर टू डिस्प्ले समथिंग व्हाट यू यूज इन पाइथन, यू यूज अ स्टेटमेंट कॉल्ड प्रिंट. आप प्रिंट लिखते हो यहाँ पे, जैसे हम अपना नाम अगर लिखे तो हम यहाँ पे लिख रहे हैं प्रिंट विवेक, ठीक है? और अगर सी सी प्लस प्लस में या सी में हम लिखेंगे, सी में अगर हम लिखेंगे तो क्या लिखेंगे हम यहाँ पे लिखेंगे प्रिंट एफ, ठीक है? हम यहाँ पे लिखेंगे प्रिंट एफ, यहाँ पे हम लिखेंगे प्रिंट एफ विवेक. अब एक बात बताओ, लाइक यू नीड टू अंडरस्टैंड दिस, लाइक print f, I know, right, that print is an output statement. Print is used to print something. Print is an output function, है ना? Output function है. It is a function which is used to print something in the output window, in the console window. But do you really think computer also understand print? राइट, ऐसा तो नहीं है कंप्यूटर प्रिंट करता होगा. लाइक लेट्स टेक अनदर एग्जांपल ऑफ एन इलेक्ट्रिक बोर्ड, राइट? लेट्स टेक एन एग्जांपल ऑफ इलेक्ट्रिक स्विच in your house, right? So right now you must be having a switchboard in your room, and if you press a particular button, if you press a particular switch, the fan will on, right? A fan will on. Okay, so now it was not automatically done. Someone would have come over there, would have done the wiring and everything, and then now you are able to use it, right? So similarly here also what happens is that print is not something which computer understand, printf is not something which computer understand. So there must be someone who is expanding this code, because you are using print because your in order to make your task easier. नहीं तो अगर आप समझो कि print के लिए भी आपको अगर 20 लाइन का कोड लिखना रहता तो आप अपना कोडिंग फिर करते ही नहीं, आप कोडिंग छोड़ देते, बोलते कि नहीं हो पाएगा हमसे, let's keep it here itself, let's leave it here, right? But what they give you is that they give you certain things, they give you certain steps, certain functions which make your life easy. But the point is that compiler को बताना होगा ना कि वो फंक्शन क्या है, वो फंक्शन कैसे काम करता है. someone has to expand that, right? किसी ना किसी को उसको आगे वो चीज बताना होगा कि वो क्या होता है. someone has to give them a reference of all these things. Okay, so वहां पे क्या होता है, preprocessor comes into picture. Okay, what happens is that preprocessor comes into picture. तो जब preprocessor करते हो ना, तो आप whatever functions you are using, it expands. Okay, it expands all these things before the compilation can begin, before compile takes over. It expands all the source code. Okay, so it is like let's take an example like has defined max rows 10. So preprocessor finds all the places and replace max rows with 10 in the files of the project. This is just another example. आपने क्या किया, आपने यहाँ पे एक max row लिखा, max row का एक वैल्यू दिया 10, और आप जहां जहां max row लिखोगे वहां पे कंपाइलर क्या करेगा, उसको रिप्लेस कर देगा 10 से, क्योंकि आपने ऑलरेडी वहां पे डिफाइन करके रखा हुआ max row 10. They have already defined it earlier. Okay, so what preprocessor does is that, in short, if I have to tell you, it expands the source code. Okay, it expands the source code. अगर आप सिर्फ इतना ही समझो, अभी इतना ही काफी है. Expands the source code. Okay, it expands the source code so that the compiler can take over from there onward. So all the preprocessor commands written in high level language are processed by the preprocessor before the compiler takes over. Okay, this is what the role of a preprocessor is. Then we have something called as linker. So linker uses the object files created by the compiler and then uses the predefined library objects to create an executable file. Okay, तो बेसिकली आपका देखो, आप यहाँ पे एक बार स्टेप को समझो. ओके, लेट्स ट्राई टू अंडरस्टैंड द स्टेप्स वन मोर टाइम. सो बेसिकली you had your source code. Okay, then preprocessor came into picture. Preprocessor came into picture, right? It expands. So now it becomes expanded source code. Okay, expanded source code. From here what happens is that compiler came into picture. Okay, and it became what? It became like it became an object code. Okay, let's take into object code. It became an object code. Now what is happening is that a linker is coming into picture. So what is a linker? Linker uses the object file created by the compiler. So now linker is coming into picture, which was created by the compiler. Okay, object code created by the compiler, and then uses predefined library objects. अब यहाँ पे कुछ predefined library objects हैं इसके पास, and now it is creating an executable file. Now it is generating an exe file. Okay, so your compiler is not the one which generate the exe file, the executable file. It is the linker which is doing that. Okay, so now you came across so many things. You came across assembler, you came across compiler, you came across interpreter, you came across source code, object code, linker, right? A preprocessor. Okay, so now these are the things which you need to understand. So अगर आपको लगता है, if you were thinking like that your source code is directly getting converted into executable file, wrong. These are the steps. Source code, preprocessor will come into picture. It will become expanded source code. The expanded source code compiler will take over. It will become an object code. Object code. Now here again assembler will also come, but we'll ignore that part for the time being. So now linker is coming into picture. Linker is coming and it is using some predefined library objects, and then now it is making an executable file. Okay. So these are this is journey of a file, right? We can say that the journey of a file. Okay, journey of a file. Okay, so these are the steps that a computer program goes through, and these are this was nothing but introduction to coding. So I hope that you understood all the term, because we are going to use a lot of these terms very often in all of our upcoming videos. So that's all for today. Thank you so much.